Welcome to this M1 video on vertical motion under gravity. So, the force of gravity causes all objects to accelerate towards the Earth. Now, obviously, if you ignore the effects of air resistance, then this acceleration is constant and doesn't depend on the size, weight, mass of the object. So what we look at is that A is now going to be classed as G and equals 9.8 meters per second squared, and it's going to act downwards. Now use 9.8 unless it tells you otherwise. I know in physics sometimes you use 10, and we do sometimes in maths, but in mechanics we're always going to use 9.8 unless it specifies a different value, e.g. like 10 or 9.81, etc. Okay, but otherwise if it doesn't specify, use 9.8. Now obviously if you take your direction of motion like vertically upwards, then it would be a negative 9.8. okay, because it's always going to act downwards. And this then enables us to do other questions where we might not be given or assumed to be given enough information, but we know that acceleration due to gravity is taking place. So that gives us a constant value for each of these questions. So I think the best thing to do is to jump into the first example. And here it is. A ball falls off a tabletop. The tabletop is 1.2 meters above the floor. Find A, the time it takes for the ball to hit the floor, and B, the speed with which the ball strikes the floor. So in terms of what's happening, we've got our tabletop, and then we've got the floor. Okay, so this is the floor, and this there is the tabletop. So a ball is falling off this and then landing down here, and this height is 1.2 meters. So I'm going to take my downward direction as positive. So if I take this downward direction as positive, I get, well, u is going to be equal to 0 because it's not being thrown with any speed, it's just falling off. So it's going to start at 0. A is going to be g. I'm just going to use g. G is going to be 9.8, and it's going to be a positive g because my downward direction is positive. S is going to be 1.2, and then in this first instance I want to find t. So what has S, U, A and T in it? You guessed it, S equals UT plus a half AT squared. So substituting in my values, I get 1.2 equals 0 plus a half g t squared. So half g is going to be 9.8 divided by 2, which is 4.9, and then 1.2 divided by 4.9 is going to give me that t squared is 0.2449 and so on, and then square rooting my answer, and then taking the positive answer because it's going to be time, then t equals 0.495 seconds to 3 significant figures. So that's part A done. So that was part A. Now part B, we want the speed with which it strikes the floor. So that is still U equals 0, A equals G, S equals 1.2, and this time we want to find V. Now, I know that we know what T is, but if I can help it, I don't want to use a value that I've previously calculated. Sometimes I've got no choice, but if I can help it, I'd rather not, because then I don't compound my mistakes later on in the question, if I made a mistake. Right, so what has U, A, S and V in it? So that is V squared equals U squared plus 2AS. And remember, always write down your formulae, not just because it is good practice, but it will help you remember you won't have to learn these formulae. So 0 squared 2G times 1.2. So that gives me that V squared is 23.52. And square rooting my answer, I get that V is 4.85 meters per second, and again to 3 significant figures. Sometimes the question might ask for 2 significant figures, or 1 decimal place, 2 decimal places. So just go with what it says in the question. If it doesn't say anything in the question, then use your own judgment. Look at the values that you've got for an answer. This one, perfectly reasonable answer would be to 2 significant figures for a speed. So this would be actually 4.8, because it's 4.849. Okay, so it'd be 4.8 meters per second. And that rounds off the first example. Okay, hopefully you can see these are no more challenging than the previous set of questions. It's just bringing in vertically thrown or dropped items now, and acceleration due to gravity. So let's look at the second example. So here I have a stone is projected vertically upwards from a point 2 meters above the ground with a speed of 24 meters per second. Find the greatest height above the ground the stone reaches and the flight time of the stone. So as I usually do, a little sketch just to look at what's going on here. So this now is the floor, and this is my starting point, 2 meters above the ground, and it goes up in the air and then comes back down and hits the ground there. Okay, so I'm going to take upwards as positive, and this distance here up to its maximum height, that's what I'm going to call S. Okay, so let's find the greatest height. So for that we've got U equals, this is part A, 24 meters per second. V, so at its greatest height V will be 0, because it's just when it stops moving upwards at that instant it's 0 before then starting to accelerate downwards. A would be minus G this time because I'm taking upwards as positive, and S is what I'm trying to find. So what formula contains all of these? And it is V squared equals U squared plus 2AS. So V squared is 0, U squared is 24 squared. Now it's going to become minus because of the minus G, so 2GS. So take the 2gs to the other side. 2gs is equal to 24 squared, which is 576. And divide that by 2g. Remember, g is 9.8. And we get that S is 29.3877 and so on meters. But that's not the height, is it? Because that's the height of S. But we started 2 meters above that. So the greatest height, or therefore the greatest height, is 29.4 plus 2 meters. So that's going to be 31.4 meters to 3 significant figures. Okay, so don't forget about that little 2 there. Now let's move on to B. So B, we want the flight time of the stone. So there's a few ways in which we could do this. Now, if this had started on the ground, then we could go the total distance, or we could find the time to the top and then double it. But because it starts above the ground, it does make it a little bit more difficult. But we can set our distance as -2, because it's going to go up, it's going to come down to there where it's level, and then it's going to go past it to another 2 meters. So if we set S to -2, then U is going to be 24. A is going to be -G, because we take it up as positive. And then T is what we want to find. So what formula do we use here? Well, it's like it happens in a lot of these. S equals UT plus a half AT squared. So S is -2. And then we've got 24T minus a half GT squared. Okay, so a half G is 4.9. So take that to the other side. So we've got 4.9 T squared minus 24T minus 2 equals 0. Now, remember at this point, if you can't factorize, which we can't here, sometimes you can multiply by a number to simplify it, but not really possible in this case. So if you can't factorize, use the formula, write the formula down, and then jump to the answers. Don't just put it in your calculator and jump to the answers, although that is what I've done here. Okay, make sure you use, you write down the formula and substitute in to that formula. Okay, so you're not just writing down the answers. Now we get 2 answers out of this. Okay, and the 2 answers here to 2 significant figures. Now obviously we can ignore the -1, because that is like assuming it was thrown back here. So it's going to be a negative time. So we want the positive time. So therefore, time of flight equals 5.0 seconds to 2 significant figures. Okay, so I've used 2 significant figures there. I've just used my own judgment. Even if I did 3 significant figures, it would just be 5.00. Even, you know, if I did it to the whole number, it'd be 5. So it's all rounded to basically 5 in this case, unless I went to 5 decimal places. Okay, so that is now the final part of that. Hopefully you've seen, how straightforward a lot of these questions are. Now, if at this point you've found this video useful, then hit that like button. If you're yet to subscribe and you do want to see more videos, please hit the subscribe button. Obviously it does help me if you subscribe, and doesn't affect you in any way. You'll just get shown a few more of my videos. And if you've watched a few of my videos now and you want to try and help me out a little bit, then please consider hitting that join button. Okay, every little bit helps. So join for a month, join for longer, it all helps me. Now I've got 4 questions coming up, starting here. The first question I just made up myself as a nice easy question to start with, and then 2, 3 and 4 are past exam questions just based on this vertical one. 4 is a particular familiar one. I remember that one quite vividly from the exam series. Anyway, pause the video now to attempt these 3 questions, and pause the video now to have a go at this 4th and final question. Hopefully you've now had a go at these 4 questions, so stick around for the answers coming up next. Okay, so we've got a ball being dropped from the top of a building onto the road below. So I'll just draw my little sketch of this building. There it is, the ball is being dropped from up there and landing down there. The building is 48 meters high. I'm going to take down as the positive direction. Okay, so U in this case is 0. S is 48. A is G, a positive G, and we want to find T. So that means we're using S equals UT plus half AT squared. So substituting in what I know, 48, that's going to be 0 plus a half GT squared. So take the 48 divided by 4.9, which is the half G, and we get the T squared is equal to 9.796, which when I square root, I get the T is 3.1 seconds to 2 significant figures. Now moving on to B. Now we want to find the speed it hits the road. So everything is the same. U is 0, S is 48, A is G, and we want to find V. Now I always write these down again because in the second part of the question, sometimes changing the direction you're using as positive makes your life a little bit easier, and you can do that. Okay, so always rewrite these before you start. So U, S, A and V, that is V squared equals U squared plus 2AS. So that is V squared equals 0 plus 2G times 48. So that is 2 times 9.8 times 48. And that is 940.8 meters. So square root of my answer is 30.7 meters. And I'll do this to 3 significant figures there. So 30.7 meters per second, I should say. Do apologise. And that is the nice straightforward question 1 to get you just into these. Let's now look at question 2. So here a particle is projected vertically upwards from point O with speed u meters per second. 2 seconds later is still moving upwards with the speed of 1/3 meters per second. Calculate the value of u. So what's happening is I've got this particle and it's initially at u, and then 2 seconds later it's now at 1/3 u, and time there equals 2 seconds. Now I'm going to take upwards as positive in this, so u equals u, v equals 1/3 u, a equals negative g, t equals 2. So what has u, v, a and t in it? And that is v equals u plus a t. So that is 1/3 u equals u minus 9.8 times 2. So 9.8 times 2 is 19.6. Taking it to that side, and 1/3 u subtracted from u gives me 2/3 u on this side. So u equals that 19.6 times by 3 divided by 2. So u is 29.4 meters per second. And that is the exact answer there. And that, of course, is part A. Now, part B, the time from the instant it leaves O to the instant it returns. So this is going to be S equals 0. T is what we want to find. A is minus G, because I'm still taking upwards as positive, and in this case I have to use the value I worked out earlier because I don't have a fourth value. So u equals 29.4. So what formula contains all of these? And it is S equals ut plus half at squared. So S is 0, and we've got 29.4t minus 4.9t squared. So I can take t outside and got 29.4 minus 4.9t. So therefore t equals 0, or 29.4 minus 4.9t equals 0. So rearranging, that is going to be 29.4 divided by 4.9, and that's going to give me 6 seconds. So time taken is 6 seconds. And obviously the first time times 0 would be when it was initially thrown. Now let's have a look at question 3. So we've got a ball A is thrown vertically downwards with a speed of 5 meters per second from the top of a tower block 46 meters above the ground. At the same time, another ball B is thrown vertically upwards from the ground with speed 18 meters per second. The balls collide. Find the distance of the point where they collide from the point where A was thrown. Right, let's have a little sketch of what's going on here. So I have my tower block here and it is at the height 46 meters. And then I've got A, let me do A like that. And that is being thrown down with a speed of 5 meters per second. And then I've got B being thrown upwards at 18 meters per second. And I'm just going to change colour, and then somewhere in between A and B collide. And I want to find the distance from the point where A was thrown. So I want this distance S here. So to make it easier, because I want that distance, I'm going to take down as being positive. Okay. Now that S that I want to find, I'm going to call it SA. And then this S is going to be SB. And what I can say is SA plus SB equals 46 meters. Now for A, that's where we're starting off. So for A, U equals 5 meters per second. S equals SA, and that's what I'm hoping to find. And then we have A is equal to G, and T is equal to T, because the time is going to be exactly the same for A as it is for B. So what I want to do is effectively find an expression for T, and then I can equate those two T's because they'd be equal, and then I'd have an expression with SA and SB in it. And again, I can substitute in this then to find out what SA is. That's my A. So I want a formula with S, U, A and T in it, and that is S equals UT plus half AT squared. So that's SA equals 5T plus 4.9T squared. Now for B, so previously we used down as positive for A, but for B we can take upwards as positive. Okay, so for B upwards is positive. Okay, for A downwards is positive. So just make sure if you are changing your direction of positive and negative, then you are labeling it clearly for the examiner to be able to follow. So U equals 18, S equals SB, A equals minus G, and T equals T. And then I've got S equals UT plus a half AT squared. So that's SB equals 18T minus 4.9T squared. Okay, now what I can do is take 1 and 2, and I can effectively equate the t's, or because I've got t squareds in both, it's hard to make it t equals in this case, but if I add the two together, so if I add 1 and 2, on the left I'd get SA plus SB equals, and then it's 5t plus 4.9t squared plus 18t minus 4.9t squared. So SA plus SB we've already established is 46. And then 5t plus 18t is 23t. And the 4.9t squared minus 4.9t squared cancels. So this now gives me that t equals 2 seconds. And I can use this now to find out what SA is. So we're going to sub t equals 2 into equation 1. So that's SA equals 5 times 2 plus 4.9 times 2 squared. So 4.9 times 2 squared plus that 10 gives me that SA is 29.6 meters, and that is the exact answer there. Okay, so it's 29.6 meters down. And there we have it, question 3 done. Okay, now you notice I did switch the directions of the positive. Okay, you can do that, and it does make your life so much easier in questions like this. Okay, but if you didn't, you should still get the same answer out. You might just have to be a little bit careful with your signs as you go in through the question. Now let's have a look at question 4. Okay, I describe this as a bit of a classic question. A ball is released from rest at a point 10 meters above a wooden floor. Each time the ball strikes the floor, it rebounds with 3/4 of the speed it struck the floor with. Find the greatest height of the floor above the floor reached by the ball the first time it rebounds the floor, the second time it rebounds the floor. So if I think of a little diagram here, I drop a ball, it drops, hits the floor, rebounds up the floor like this. Okay, let me just rub that out. I will put a ball on the floor. So that's the kind of first rebound that I'm looking at. Okay, so what I'm going to do is do this in a couple of little sections. So initially, U is equal to 0. A is equal to, I'm going to take downwards as positive here. So A equals G. S equals 10, because this is 10 meters. And I want to find V. Okay, because then the second part, then V will be my U. So I've got S, U, A and V, so that is V squared equals U squared plus 2AS. V squared equals 0 plus 2G times 10. So 2 times 10 is 20 times 9.8 is 196. So V is the square root of that, which is 14 meters per second. Now, as it's now rebounding, it's going to be rebounding with 3/4 of that. So times that by 0.75, and we get this at 10.5 meters per second. So now U equals 10.5 meters per second. I'm taking upwards as positive. V is going to be equal to 0 because we want to find its greatest height. A is equal to minus G, and S is what we want to find. So again, now it's V squared equals U squared plus 2AS. V squared equals 0. 10.5 squared is 110.25 minus 19.6s. So it's 110.25 divided by 19.6, and we get a height of 5.625 meters. Okay, you can round it off for this answer if you wish, but remember then use the full answer when we're kind of going forward from there. Now we'll move on to part B. So part B now is going to happen again, isn't it? So, you know, if you follow my bit now in purple, it's going to go down to here. So U equals 0, V we want to find. Okay, so we've got U equals to 0, V we want to find, A equals minus G, and S equals 5.625. So that is V squared equals U squared plus 2AS. So V squared equals 0. Oh, sorry, on this one we're going to take downwards as positive. So that is a positive G there. Okay, we could have taken upwards as positive. We would have ended up with a negative V, but it's easier this way. So 2 times 9.8 times 5.625. So 2 times 9.8 times 5.625. And that gives me 110.25. Which of course means that V is 10.5. So what I actually could have said here because it's kind of obvious now I'm seeing it by symmetry. Okay, V at the bottom is 10.5. Okay, so it hits the ground at 10.5 because it's leaving at 10.5, so it hits at 10.5. So now I want to do 10.5 times 0.75. So our new U is 7.875. Okay, and what I would do is take my, my V, and I would times it by 3/4, just show the examiner me doing that. So we want the height it goes to is maximum, so that's when V is 0, A is going to be minus G, because I'm going to take upwards as positive, and S is what I want to find. So V squared equals U squared plus 2AS. Just going up to here. So V squared is 0, U squared is 7.875 squared minus 19.6S. So square that, divided by 19.6, and we get that S is equal to 3.16. This is the three significant figures. And there we have it. I think when I originally did this question, I actually did one diagram in the beginning, and then I did a second diagram showing what was happening here. Okay, because this is then the V, and I labeled them slightly different, given the U's and the V's just additional letters. But you kind of hopefully followed what I did and got the same answers as me. So there we have it. This is the constant acceleration unit in vectors, in M1 done. The next unit, the next series of videos that we're going to be moving on to are going to be the vectors in mechanics series of videos. So come back soon to watch those, or if you're watching these a little bit later, they might already be up. Anyway, see you next time. Don't forget, like, comment down below, subscribe or join.